in this question it is given that let fx is equal to this thing for x lying between -2 and -1. This if mod x is less than 1 otherwise, where box T denotes the greatest integer less than or equal to T. If M is the number of points where f is not continuous and n is the number of points where f is not differentiable, then the ordered pair m comma n is, you have to find the correct choice. First, let us redefine this function. It is clear that between -2 and -1, the value of box x will be -2, hence the function will become equal to sine of x plus 2 upon x plus 2 for -2 less than x less than -1. And this thing can be written as -1 less than x less than 1. And it is clear that for x equal to 0 both are giving same answer, but when x is lying between 0 and 1, in that case this is 0 and this is a positive number, hence I can say 2x is bigger. But when x lies between -1 and 0, it is still 0, but the value of this will be negative, hence this will be bigger. Therefore, we'll be writing as -1 less than x less than or equal to 0, 0, because this will be bigger as this will be 0 and this will be negative. And because for x lying between 0 and 1, this will be still 0, but the value of this will be positive, hence this will be bigger. We'll be writing 2x. If x lies between 0 and 1, equal to 0 can be written here also, because both are giving same answer for x equal to 0. And 1 is there otherwise. It is clear that the value of function fx is changing at -2, -1, 0 and 1. Hence, chances of discontinuity or non-differentiability are at these points only. At all other points, fx is sure to be continuous, because between -2 and -1, this is continuous differentiable, this is continuous differentiable, and division of continuous and differentiable function is always differentiable function. Between -1 and 0 it is constant function, hence continuous differentiable. Between 0 and 1, polynomial function, hence continuous differentiable. Therefore, the only points required to be checked are -2, -1, 0 and 1. First of all, let us check the continuity at -2. It's clear from here that as x tends to -2 plus, that is x tends to -2 plus, the value of the limit of this will be 1. And when x tends to -2 minus, because this comes in otherwise portion, the value of limit of this part will be also 1. Hence, I can say at -2 it is continuous function. Now let us discuss continuity at -1. At -1, if I find limit x tends to -1 minus, in that case this will be used sine of x plus 2 upon x plus 2, hence we will be getting sine 1. And limit x tends to -1 plus, clearly from here I'll be getting 0, hence At -1 it is sure to be discontinuous. At 0 it is clearly continuous. At 1 also it is clearly discontinuous because limit x tends to 1 minus the value of fx will be 2x, hence we'll get the answer 2. And limit x tends to 1 plus it will be 1, therefore answer will be 1. This I have obtained from here. Hence at 1 also it is discontinuous. Hence we have got the conclusion that this function is continuous only at -2 and 0. At -1 and 1 it is discontinuous, hence non-differentiable. Now we'll be checking the differentiability only at -2 and 0. Recall that for x slightly more than -2, the value of fx is sine x plus 2 upon x plus 2. And for x slightly less than -2, it is 1. And for equal to -2 also it is 1. Now for checking differentiability at x equal to -2, I am going to use the proper formula of finding derivative, not the shortcut way. In which type of cases shortcut way is not useful, you must have studied in your class. Else see my video lecture on differentiability of JEE mains level. For finding left hand derivative at -2, it is clear that f dash -2 plus will be equal to f of -2 plus h minus f -2 whole upon h. Limit h tends to 0 plus also. This is equal to limit h tends to 0 plus sine of h upon h minus 1 whole upon h. That is limit h tends to 0 plus sin h minus h upon h square. That is equal to limit h tends to 0 plus cos h minus 1 by 2h. That is limit h tends to 0 plus minus sin h upon 2. That is answer is 0. Here I have used L'Hopital's rule. And left hand derivative at -2, that is f dash -2 minus is equal to limit h tends to 0 plus f -2 minus h minus f -2 upon minus h. Note that I am dealing with left hand derivative, still I have written plus. You must have done the practice of differentiability while preparing. This is equal to limit h tends to 0 plus 1 minus 1 upon minus h. The answer is 0. Hence the function is differentiable at -2. And second possible point of differentiability is 0, because at 0 also it was continuous. It is clear that for finding left hand derivative at 0, you will differentiate it in normal way and take limit as x tends to 0 minus it is 0, answer is 0. And f dash 0 plus means limit x tends to 0 plus, differentiate it in normal way and take the limit, we have got the answer 2. You must be knowing this shortcut way of finding the left hand derivative and right hand derivative. and because they are unequal, hence I can say at 0 it is non-differentiable. Hence finally we have got the conclusion that fx is discontinuous at -1 and 1 only, but non-differentiable at -1, 0 and 1. Hence number of points of discontinuity are 2 and number of points of non-differentiability are 3. Hence I can say C is the correct choice.